In this lesson, we will introduce the ESP32 microcontroller, the key component in our IoT air quality monitoring station. By the end of this lesson, you will understand what the ESP32 is, why is it so ideal for IoT projects, and how it fulfills its role into our specific project. First of all, let's go over what is a microcontroller. A microcontroller is a small computer designed to do one specific task. It's like having a personal assistant that's very good at one specific job, whether it's controlling the temperature, operating a robot, or making sure that your washing machine is done on time. A microcontroller has everything built right inside of it, like a processor, the brain that thinks, the memory, the brain's notebook for short-term or long-term storage, and of course the input and output ports, which interact with the world around us, like sensors and motors. What is a microprocessor? A microprocessor is also like a brain, but more powerful and needs assistance from other parts to function. It's what you find inside of your computer or your phone, and it's what we will find later on in a Raspberry Pi. The microcontroller is like a specialized machine that does only one task for the whole day, like sorting packages by size. The microprocessor is like the manager, who oversees multiple machines. It also communicates with the office, handles logistics, and makes sure that everything runs smoothly. The ESP32 is a powerful microcontroller designed specifically for IoT applications. In IoT projects like this one, having a microprocessor that can handle connectivity and data processing in one package is essential. The key features of the ESP32 are built-in Wi-Fi and Bluetooth. It combines a CPU with integrated Wi-Fi and Bluetooth, making it highly versatile for projects that require connectivity. It enables wireless communication and access to the internet. A dual-core processor. It provides efficient processing power to handle multiple tasks simultaneously. Low power consumption. Ideal for battery-operated devices and energy-efficient systems. Wide compatibility. Supports popular programming environments like the Arduino IDE and MicroPython. These features make the ESP32 a top choice for projects that need to collect data, process it, and share it wirelessly, which is something that we will be doing in our project. So, how will the ESP32 fit into our project? Well, it will be collecting the temperature and humidity data from the AHT sensor. It will send this data to the TFT display, allowing for real-time monitoring. The ESP32 will also act as a web server. This will make the data accessible over Wi-Fi to any device connected to the network. To effectively use the ESP32 in this project, you will need a basic understanding of its pin layout. It has GPIO pins, or general-purpose input-output pins. These pins allow the ESP32 to interface with sensors or motors. Power pins. The ESP32 needs a stable supply of 3.3 volts or 5 volts. You will be connecting external components to these pins such as sensors and motors. Communication pins. These include serial communication interfaces like SPI or I2C used to communicate with displays and sensors. In the upcoming lessons, we will explore how to connect all of the pins to the AHT sensor. Now that you have a basic understanding of the ESP32 sensor, the next lesson will go over the AHT10 temperature and humidity high-precision sensor. We will go over how it works, why is it suitable, and how to connect it to the ESP32.